I taught you about the sum of a geometric series. I also taught you about the sum of an arithmetic series. Let's just recap. We start from the known to the unknown. So we said if I want to calculate the sum of an arithmetic series, I would say Sn is going to be equal to n all over 2. Okay? Then we have 2a plus n minus 1 multiplied by d. Ne? And then we also have this one of Sn, which is going to be equal to a r to the power of n minus 1 all over r minus 1. So this one works if we're dealing with geometry. Now, the next thing that we're going to talk about is this one here. We are going to be calculating something called the sum to infinity. We are going to be calculating sum to infinity. Now, sum to infinity, it is a geometric series. The only series which can have a sum to infinity is a geometric series. And then, when does a series have a sum to infinity? Is if it converges. Now, we'll speak about converging. Our geometric series, they are divided into two. There are those that diverges, and then there are those that converges. Now, which one diverges? Which one converges? The person who determines whether your series is going to diverge or converge is R. Now, let's take a geometric series S1Z from the previous ones. We can just take any one of them. And then from there on out, I will tell you whether it's diverging or converging. Let's check a geometric. Yeah, let's look at this one that Amu was doing, this one. Number C. We all agree this one is a geometric series. Okay? Now, if it's a geometric series, it can either diverge or it can converge. Now, what determines whether it's going to diverge or converge? It's the value of R. You need to calculate R. Now, how do you calculate R of a geometric series? You say term number 2 divided by what? By term number 1. Okay, if we check number 1C, let's check what do we have here. We have 1 all over 4 divided by 1 all over 2. We have 1 all over 4 divided by 1 all over 2. What do you get for this one? 1 over 2. Now, as diverging and converging, your series is going to converge if R, it's a value between -1 and then the value, it should be greater than -1, but it should be less than 1. The series converges. We just calculated R here. If you look at your R on your number line, here's what we are saying. And then a series is going to converge if R is between -1 not included. We can't count -1. It's going to be between -1 and 1. Any value in between here is going to make the series to be convergent. Can you give me examples of values that can lie here? Give me a value that can lie here between -1 and 1. Which one? 0. We can say 0. Okay. When R is equal to 0, the series is going to converge. When R is equal to 1,5, the series does not converge. Agree 1,5 is this side. It diverges. Right? But let's say I got R like this one. My R is 1 all over 2. What will you say about this series? It converges. Okay? For the fact that the series converges, they can ask us sum to infinity. So instead of using Sn, here we have the right to use sum to infinity. And then we're not going to worry about each other. They will tell you, calculate the sum to infinity. But as a learner, you need to know, the only series that you can calculate is sum to infinity is if the series does what? It converges. Let's go back to our example then, so that you'll see what we're talking about. Example number 15. So we do have a formula to calculate the sum to infinity, which looks like this. It says Sn is going to be given as A1 minus R. And then it's 2 marks. These 2 marks is very important. I want it, these 2 marks. So if we look at example number 15 here, they will say, calculate the sum to infinity. I don't have to guess here. They told me calculate the sum to what? To infinity. So if they say calculate the sum to infinity, it already means that the series is going to be convergent. I don't have to prove it. The series is convergent. So what am I going to do from here? I am going to take the formula that they gave me to calculate sum to infinity. What does it say? Yeah, what is the difference between lega and aina n, and then sum to infinity is going to be given by A all over 1 minus R. It's not R minus 1. Yeah, and then the good news is that is there on our information sheet, so we shouldn't worry about it. So for me to calculate the sum to infinity, I need to know what is A. Let's take this series here. What is the first term? It's 1 all over 2. No? And then I can calculate R. It's that one. So what is going to be my R? It's 1 all over 4 divided by 1 all over 2. Okay? which is going to be what? 1 all over 2. As soon as I have A and R, I'm good to go. I'm simply going to take this and substitute it here. You're going to have 1 all over 2, okay? All over 1 minus 1 all over 2. And then you get an answer. We give you 1 mark for substitution, and then we give you 1 mark for the answer. What you get as your answer? You get what? Yeah, and then we're done. That is why I'm saying this one is very important. This is the new sum that we're introducing. We have Sn of an arithmetic, we have Sn of a geometric, and then we have Sn of a what? Of a convergent series. And then there will be specific, calculate the sum to infinity. We are going to do the following as an activity then. Let's calculate the following. We are going to do the whole of activity 15.